So this is a probability problems. Quick pick 13, number 5. We have a couple problems similar to this one. So I would do, I'll go over quick pick 13 first. Say Regina has cards below turned face down. So assuming we don't see these cards, she will select two cards with replacement. The key term here is replacement. So the outcome of one event affect the outcome of the next event. Okay, so the question is, what's the probability that she will select number 7 both times? Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 cards. And out of these 8 cards, there are 3 cards with number 7. So the chance that you're gonna pick a card that has a number 7 or card 7 is 3 out of 8 total. Okay, so that's going to be the first card. Now for the second card, but the key term here is replacement. So I pick the first card, whether it's a 7 or not, it doesn't matter. Okay, but the chance of getting a 7 is 3 out of 8. So now I'm going to take that card, I'm going to put it back into the pile face down. So let's say we shuffle it again, and then we're now going to pick another card, the second pick, and the second card is also a number 7. So the probability of picking another card is also 7 is also 3 out of 8. Okay, so the probability of getting both cards that are both 7 is gonna be 9 out of 64. Okay, and we can kind of reduce 9 over 64, but since 9 cannot be reduced to 64 easily, because 9 can be reduced to 3, but 64 is not divisible to 3, is only divisible to 2, 4, 8. Okay, so what we can do, we can take 9 divided by 64. That's going to give us about, multiply that to 100. And so the probability of getting, the chance of getting like both cards that are number 7 is about 14%. That's what it means. Okay, 14%. So that is for number 5 on Quick Pick 13. All right. So I'll go over a couple more on the probabilities. Okay, so this is Quick Pick 14, same thing, number 5. Instead of cards, now they're talking about marbles, come in different colors. Okay, and the question here is pretty tricky, the way how they word it. So I place different colors marble in a box. So just imagine I take all these marbles and I place them in a box. Okay, and she can ask her friend Victor to reach into the box twice without looking. So not gonna look into the box, and whatever you pick, the first marble, we're gonna replace it back into the box. And the question here is, what is the probability that he selects a color other than green twice, other than green? So it could be both red. Okay, so they both could be red. Okay, so you got 1 red, 2 red, 3 red, 4 red. So you got 4 red in here. Okay, so you got 4 red, and then we have we have 1 green, 2 green, 3 green. You got 3 green, but again, we don't want green. The question is not asked any color, but other than green. Okay, and then we have yellow. We have 1 yellow, 2 yellow, 3 yellow, 4 yellow, 5 yellow. So you got 5 yellow. Okay, so we should have the total of 12 marbles altogether. Okay, you got 12 marbles. All right, so let's count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so what is the chance that that Victor's gonna pick 2 marbles that is the same color but not green, not green. Okay, so let's go with the red first. There are 1, 2, 3, 4 red. So it's gonna be the first marble. Let's say it's gonna be red. The chance of getting gonna be red, get red is gonna be four. It's gonna be 4 out of 12, and then he's gonna put the marble back into the bag. So it's gonna be the next red is gonna be 4 out of 12 again. Okay, so that is for red. What about for green? We have 1, 2, 3 green. So it's gonna be 3 out of 12 for the first marble. And then the second marble, let's say the probability get another green is gonna be another 3 out of 12. Again, since we are put the marble back into the bag. Okay, but we're not looking for green, so cross out the green even though we did the green out. And then for the yellow, we have 1, 2, 3, 4, 5. So you got 5 yellow out of 12. So the first marble is going to be 5 out of 12. Then the second one should be also 5 out of 12. So those are the answers, and you can just reduce this a little bit before we simplify it. 4 out of 12 is going to be 1/3. 4 out of 12 is going to be 1/3. So 1/3 times 1/3 will be 1/9. So that's the chance of getting the red. Okay. Now for the yellow, it's gonna be 5 times 5 is 25, and 25 over 12, which is 12 times 12, which is 144. So definitely can use the calculator for this to kind of find out the percent that's gonna happen. So you're gonna take 1 divided by 9. So that's gonna give you 0.111 multiplied by 100. So it's about 11%. It's gonna give you red. Okay. And then you have 25 divided by 144. That's going to give you 7.177 multiplied by 1.17 multiplied by 100 will give you about 17.36%. So I'm just going to go with 17%. Okay. So those are the answers to these kind of problems. Again, what is the probability that he select a color other than green twice? So this could be red, could be yellow, but not green. All right, and this is Quik Pik 15, and this is number 1. This is the only one problem on this Quik Pik because it takes up the whole page. Okay, another probability. So it's the experiment here is flip a coin 4 times, and what are the sample space? The sample space here is we have to list out all the outcomes. Okay, so let's say you flip a coin. The first time you flip is gonna either head or tail. Okay, so there's 2 possible outcomes. It's either head or tail. And you flip it again, that's another head or tail. That's the second time. Flip it the third time, it's gonna be head or tail again. Flip it the fourth time, it's gonna be head or tail again. So now you should have the total of 8 possible outcomes. Okay, 8 possible outcomes. Okay, so first one could be head or tail, head or tail, head or tail, head or tail, head or tail again. So these are called the sample space. So the sample space is when we list all the possible outcomes of the event. Okay, what about rolling a fair 6-sided dice twice? Okay, rolling a fair 6-sided dice 2 times. Okay, well, if you roll a dice, what's the chance you get another 1? It's gonna be 1 out of 6, or it could be 2 out of 6, 3 out of 6, 4 out of 6, 5 out of 6, 6 out of 6. So there are 6 different outcomes for the first roll. And then you roll it again, you have another 6 outcomes. So 6 and 6 is gonna be 36. Okay. So again, it could be 1 6, 2 6, 3 6, up to 6 6. Okay, the 6 on top is the number of dots on the dice when you roll, and there's 6-sided die. And then in the second row, same thing. It's gonna be 1 6, 2 6, 3 6, all the way up to 6 6. So we should have the total of 36 outcomes. All right. What about flipping a coin and a fair 6-sided dice? So flipping a coin, we have the total of head or tail. That's 2 outcomes. Okay, that's 2. And then roll a fair 6-side dice die again. You should have the total of 6 outcome. So 6 times 12 going to give you a total of 6 times 2 is going to give you the total of 12 outcomes. All right. The spinner below is spun 2 times. What are the possible outcomes? So think about it. You spin the first one, it could be red, and the second one could be red again. And then so it will be red, yellow, red, blue, red, green. Okay, and then yellow, yellow, blue, yellow, green, yellow, red, blue, blue, green, blue, red, blue, yellow, green, green, red, green, yellow, green, blue. So you have the total of 4 possible outcomes for the first spin, and then another 4 possible outcome for the second spin. So you should have the total of 16 possible outcomes. And the question here is like, which one of these experiments has the greater outcomes? So the answer to this question is B. But I don't think it's really important to know which one has the the greater outcomes. What's important here is that we can list out the sample space of the experiment and then list the number of outcomes. And then from there, we can compare them. Definitely have time for either 1 or 2 more. Here is the next one. Number 5 on Quik Pik 16. All right. Terence will toss a die. What is the probability that he will roll a 1 on his first try? So the probability of rolling a 1 on the first try is going to be 1 out of 6. Okay. And then he on his first toss, and then roll a 5 on the second toss. So it's going to be, well, again, a 5 is going to be still 1 out of 6. Okay, so your answer here should be 1 out of 36. So 1 times 1 is 1, 6 times 6 is 36. So the answer to this problem is C, 1 out of 36. So this is why, when you play monopolies, the probability, when you get to jail and then you have to get a double, you have to roll a double to get out. Sometimes it takes a while for you, it takes a few turns for you to get, the double 1, double 2, double 3, or up to double 6. Okay. All right, one more for this video since I have enough time for another one. And this is Quik Pik 17. Number 5, I say Morgan chooses 10 card turn face down. So one of them is 44, 1737 714. So these are the numbers on the cards. Face down. Okay, he removed a card out of the deck and take a look at it, and then he put the card back. So this is return the card. So that's called replacement. He select a second card from the deck and look at it again. Okay, so the question is, what's the probability that he will select 1 on his first try? Well, there's 1 card with a 1, there's another one with a 1, so the probability he's going to select a 1 is going to be 2 out of 10, because there are 2 cards with a number 1 on it, so it's going to be 2 out of 10. Okay, and then he's going to put the card back into the pile, shuffle it, and then face them down again. Now, what is the probability he's going to select a card, the second card, and the second card is a 3. Okay, so first card is a 1, second card is a 3. I see 1. There's only 1 card with a 3, so it's going to be 1 out of 10. So the probability is for this, we can reduce 2 over 10 is going to be 1/5 times 1 over 10. And that will give you the answer of 1 out of 50. So the probability of selecting a first card with a 1 and a second card with a 3, it is 1 out of 50. And 1 out of 50, if you want, you can divide that. Take 1 divided by 50. Okay, 1 divided by 50 is 0.02, multiplied by 100. So the probability of that is about 2%. That's what it means. So you get about 2%. Okay, or 0.02. So when they're looking for the probability, they're looking for 1 out of 100, or change that to 0.02 or 2%.